Alright, this is homework 7.2. Make sure you put your name on it and put your class period. Okay, alright, is this a parallelogram? Yes. Oh, I'm going to go ahead and say why or why not. Well, I know I've got that these angles here are consecutive and add to 180, but I don't have both consecutive angles. So I can't use consecutive angles add to 180, darn it. And I have opposite sides are congruent, but I don't have both sets of opposite sides. So personally, I would look at this and say, no, it's not, because I don't have enough information. I'm missing an angle, or I'm missing a set of sides. All right, again, here I've got opposite angles, but I don't have both sets of opposite angles. Okay, and then I've got opposite sides, but I don't have both sets of opposite sides. So I would still say no. And I would say same thing. I'm missing an angle, or I'm missing a side. All right, so now over here, yes, this one is, and it's because the diagonals bisect each other. So I'd say diags bisect. All right, here, opposite opposite sides. I'd say it's yes, and I'd say OPP, sides congruent. Terrible handwriting. This laptop doesn't write very well, but it's okay. So now I've got parallels, and I've got alternate interior angles. But now what's interesting about this is it doesn't tell you this, but your knowledge of alternate interior angles tells you that because those are congruent, these two are actually parallel, since these angles are congruent. So since that's true, I can say yes, and I can say OPP sides are parallel. All right, now here I've got consecutive angles are supplementary, so I say yes. Consec angles sup. There you go. 13. Ooh, interesting. So now it says, what must the value of x to make it a parallelogram? So now, in order to solve this, I've got to say this is a parallelogram. I've got to prove I need the opposite sides to be congruent. So I say 7y equals 4y plus 21. Subtract 4y, subtract 4y. 3y equals 21. Therefore, divide by 3, y equals 7. Here I have 45 equals 3x, divide by 3, and I get x equals 15, I think. Yeah, we'll call it 15. I could be wrong. All right, over here, it is a parallelogram, therefore the diagonals bisect each other. So 2x equals x plus 9. So that means that x equals 9. Here we have 3y minus 8, y plus 12. That gets me to 20, y equals 10. Again, show all your work. 2x equals x plus 9, and 3y minus 8 equals y plus 12. You do all your algebra and you're fine. It's 2 sheets of paper. Don't forget to staple the pages together. All right, here we go. Both pairs of opposite sides of quadrilateral are congruent. So the coordinate method. Okay, here we go. I'm only going to do one of these per deal because they're so long. Plot the points. -1. Oh, geez. Stupid. -1, up 1, 2, 3, 4, 5, 6. Oh, geez. Okay. 3, 5. 1, 2, 3, 4, 5. This is a terrible idea. 5, -3. And 1, -2. Again, it's supposed to look like a parallelogram. So if it doesn't, then you plotted your points wrong. Close enough. So now I'm trying to use the opposite sides of the quadrilateral are congruent. So I'm going to have to use the distance formula a ton. Yeah. So we do square root of all this stuff over and over and over again. All right. So we'll do square root of, let's do AB. We're going to do AB right now. And I do 3 minus negative 1 squared plus 5 minus 6 squared. This becomes 4 squared plus negative 1 squared, which becomes 16 plus 1, which is 17. All along, I bring my square root with me, so my final answer is square root of 17. Just make sure I did this right. 3 minus negative 1, 5 minus 6, good. All right, so that's AB. Now, I'm only going to care about CD, the opposite side opposite of it. And so let's do the square root of 1 minus 5 quantity squared plus negative 2 minus negative 3 quantity squared. So this becomes a negative 2 plus 3, which is a 1 squared plus negative 4 squared, which gives me 16 plus 1, which gives me 17. So I square root all of these, bring my square roots down, and my final answer is square root of 17. So now I can say that it is because you want to show that they're congruent. Square root of 17 equals the square root of 17. Do the same thing again for BC and DA, and you'll be done with that problem. All right, so now this one says diagonals bisect each other. So this one we're going to use the midpoint formula. Okay? And same idea. We plug in our values, and we find the midpoint of AC and the midpoint of BD. I'm not going to do it for you, but I'm just going to walk you through kind of how to go through these. All right. Coordinate proof, we're doing parallel now. So the definition that we're using right here says opposite sides of the quadrilateral are parallel. So that means that I have to use the slope formula and to solve for the piece. So I'm going to graph it over here somewhere like this, and then I'm going to use the points, and I'm going to show that they're parallel by plugging in the values into here. Remember to make sure you graph it and to show that they're parallel for each piece. All right. This one is congruent and parallel. So that means I'm going to use the distance formula for one of these pairs of pieces. So we can say AB, which one is it we can solve for? Okay, it looks like we're using AB for the slope of AB and the distance of AB. And then we're going to do the slope of CD and the distance of CD. Okay, so let's do this one. This kind of brings everything together. So if I want to know the slope of AB, I'm going to use the slope formula right here. And I'm going to say y2, goodness gracious, stupid. So I say AB, 6 minus 2 over 4 minus 4. This is the slope of AB. I get 4 divided by 0. That makes it undefined. So the slope of this one is undefined. All right, so now I do the slope of CD. And I say negative 1 minus 3 over negative 1 minus negative 1, which becomes negative 4 over 0, which is undefined. So my answer is undefined. Do they have the same slope? Yes. Awesome. So, problem solved. I've got my slope portion taken. Now I'm going to use the distance formula, and I'm going to come in here and I'm going to say I need to do the distance of AB. I'm going to say square root of 6 minus 2 quantity squared plus 4 minus 4 quantity squared gets me 4 squared plus 0 squared, and then this gets me square root of 16. Again, you don't have to simplify it if you don't want to. which I don't. So now I'm doing the distance of CD. So I say -1 minus -1 quantity squared plus -1 minus 3 quantity squared gets me -4 squared plus 0 squared gets me the square root of 16. So there you go. Explain how your answer to the previous problem proves the quadrilateral is a parallelogram. I say basically this definition over again. I bring this straight down. I say OPP sides are congruent and parallel. All right. Graph parallelogram. Use one of the 4 coordinate proofs. Okay, so this is where you choose your own. I've shown you how to do all of them. These are going to be kind of like on the tests. Use a different method, so we're whittling them away. You got to use 2 different methods, and then we're on to 7.3. So you have 2 questions of pick your own way. Midpoint's the easiest, least amount of calculations. Slope is the one we've been doing forever, so slope is also a pretty good option. The ones that I would avoid are the distance formulas because it's a lot of square roots, and nobody likes those. So that kind of walks you through your homework. Hope that helps.